Alright, hello and welcome back to my creating tools in Unity tutorial. Today we're going to be covering sort of loading, well, firstly using multiple tiles and like switching between them so you can paint different ones. And secondly, it's sort of like loading them in as a resource rather than just assigning them in an inspector, because it'd be a lot easier just to dump a load of sprites in a folder and then have the editor automatically read them. So that is something that we did, well I did, and I'll show you. So first off, just get the level creator. Let's create a new map and just expand it a bit. Now, first off, we've got a couple of new buttons. First off is this sprite control, so we can click refresh sprites, and we'll see it's found 12 sprites that we can use. If we click process them, we get a list now of just all these different tiles that we can use to paint. And if we just click one of them and say paint sprites true and enable the cursor, just click, we can click and, painting sprites. So let's create a little happy face. Yep. And again, we can also still paint areas. So if we just click there and there, and do that, we've painted an area in the same sprite. We can switch between them. So, oops, go back to paint single, and then again, we can like paint these. So let's give them fucking eyebrows or some shit. I don't know. I ain't a very good artist, but yeah, the point. Yeah, and let's go how we do that. But sorry, no, yeah. So let me show you how we did that. Okay, so first off, we got a few additions to the level creator script. We've got this new variable that stores a sprite processor, which is what loads our sprites in from the folder and processes them into game objects, because one of the things I chose to do was switch the tile placement from just changing the sprite on a tile to actually creating a new game object with that tile sprite, because I believe that'll give us a lot more flexibility. So say if you wanted to have like an animated sprite or whatever, or I think one of the things Unity said was like programmable tiles or something, where say you could have like a gameplay element attached to the tile, so a force field, I said force field, or like an alarm tile, so if you walked over that tile, then it'd set off an alarm. So you could have something like that, and it'd be easy to implement than if we were just switching the sprites on a tile. So that's why I've changed the tile painting to actually create a new game object, or instantiate a tile, rather than just switching the sprite. Next, we've got a public game objects array, which is just the tiles that we can use. So this list is where all the tiles that we can paint are stored. And the current tile to paint is the one we've selected. And that is used on the painting, I believe. Where is it? No. Should we paint tile? Yes. So if the current tile to paint is null, so if you've not selected the tile, it won't do anything. But if we do, it will call the active layer that should we paint tile. And next, we've got a couple of methods that just reference stuff in the sprite processing class. So first off, we've got to check to make sure it's not null, and if it is null, we create a new one. And then if we're clicking refresh sprites, we read sprites from the input folder, and that is basically what it looks at the base folder, which I'll get onto in a minute, where you put in your sprite sheets and the script reads from it. Next, this was mainly just for debugging purposes, so I could see that it was finding sprites. This will basically return the number of sprites found from the sprite processor. So if it's not got a sprite processor, it'll just return 0. Otherwise, it returns the number of sprites that were found. And again, we got a process sprites, which basically takes all the sprites it's found and converts them into a prefab game object, which I'll go into detail in a minute when I cover the sprite processor script. But again, it's just as a check to see if it's null and initializes it if it is null, sorry, and then calls the sprite process method. Was there anything else for this one? Do not think so. Alright, so next up is the Sprite Processor script. This is not a mono behavior, so you can take out the mono behavior import because we don't need that. We're just using it to read in sprites and send them elsewhere for the fun of it. Basically the idea behind this is we want to be able to drop all our sprites in a folder, and then this class will find them, and then create prefabs out of them automatically, and then assign them into the level creator script, so you don't need to drag and drop them automatically and stuff. So I'll just show you that quickly, because we use the resources folder. So if I go here, we've got a new folder called resources, and if we open that, first we've got raw tiles, which is where I've put my sprite sheet, which has 12 sprites on it, which I just I created these for loud or quiet, so I'm just using these as an example. Next, on the output, you'll see that we have 12 prefab tiles, and they've got the tile script, we've got a sprite renderer, and each of them has a different sprite. And yeah, so this is done. Basically, when we are, actually I'll get onto it. So basically, first off, this just checks. This is like, sorry, I'm just trying to think about it best to explain this. Because, all right, on this input folder path, this is where the tiles are located if you were looking from outside the project. So say if we went on to the Finder and we wanted to go to it, we'd go to application.datapath, whatever that would be, then resources, then tiles, because this application.datapath takes you to the, I believe it's the project folder? Yeah. But, so this is basically to make sure that the directory that we wanted to read and write files to exists. So that was more of a debugging thing than anything. You don't really need it, but just to show you where the files are going into and coming out from and whatnot, I have that there. Next, we use this resources dot. Oh, we don't need that actually. We can get rid of that. Yeah, that was just a debugging thing. Sorry. So what we have here is a method, a class called resources, which is part of Unity, you know. And we load all sprites, and we pass it in a type. So we're saying we want to load all the sprites that we can find in this location, and we push in this input folder resource local, which is a bad name, but yeah. And if we look at the variable here, import folder resource local is just the raw tiles folder, which corresponds to the one we had here, which is in resources. And when you're using the resources class, I think like the parent folder, so the top folder is the resources folder, and then we can just say, like, instead of having all this application.datapath resources / raw tiles, we can just say raw tiles, because it's assuming that the resources folder in the Unity, your project, sorry, is like the top of the folder hierarchy. So it just assumes that's the start and then looks for folders with the name equally, and that's how it works. Hopefully that makes sense. So basically, if you're using resources.load all you need to do is pass in the name of the folder that's in the resources folder that you have. I tried to use like a multi-layer, what's it called when you have like folders within folders, like hierarchy or some shit? I don't know. But I tried to do that. I couldn't get it to work. You probably can do it, but I didn't really need to for this bit, so I didn't. Then we just debug the sprites that have been found.length to see that we have actually found sprites. And these are stored in the sprites that have been found. So this is just like a temporary store of all the sprites in the folder at the import folder resource local. And next we have a method, just again, this was just for debugging, so we could see in the inspector. So if I click on here, you'll see that we've not actually, it's not found for sprites, but we refresh. We found 12 sprites in that raw tiles folder. So that was just to know that you had found the sprites again. Finally, we've got process sprites. Now what this does is it goes through all the sprites that have been found. First off, it'll perform a check if we have if we have already like created a prefab of this particular sprite. So we check this by checking if a file that exists. We add the output folder path because we're not using resources, so we need to have the whole path of the file, including the Unity project location and resources and output tiles, because that's where we're writing them to. And then we're adding tile underscore whatever the sprite's name was, and then .prefab, because you need this extension to create, well, that is the extension for prefab files. So if you drag something into the folder hierarchy, it becomes a .prefab. And if a file already exists under this name, it's going to assume, all right, we've already created this kind of prefab, we don't need to create it again. So we'll skip it. If it can't find this file, it'll create a new game object and then just adds like a sprite renderer, sets the sprite, adds the tile component, sets the name of the game object, and then calls this prefab utility .create prefab. And then this is for when we are creating the using the create prefab, we only need to say assets / resources / you don't need to go for like the whole what is it? You don't need to do the whole file path again. You just need to do assets / resources plus output folder resource local, which is where we're going to put our prefabs that we are creating with this script. And then it creates the file, and then we call asset database.refresh. This basically just refreshes the list of assets in the project, so that the new sprites or game objects that the new prefab, that we've created will appear in the inspector. Then we just destroy the instance in the world of the prefab because we don't need it anymore. Finally, we convert this to an array by we actually create an array of game objects by using the resources.loadAll in the output folder, and this will just find all game objects in the output folder, which is just output tiles. And then it will go back to the level creator and it will set the tiles list, which I showed you here, which again is just a list of game objects which we can place in the world, and it will create that. Yeah, that's how the Sprite Processor works. Okay, since I've switched to using or instantiating game objects instead of like changing the sprites on a tile, I've had to make a few alterations to how the painting of tiles works. So first off, you'll notice that, well, this was the old code where we'd get the tile and set the sprite if it wasn't null. But instead, what we have to do is we round the mouse and scene x and y to an integer and store that. And then we pass it into the tc.setTile with the x and y and the current tile to paint, which is a game object, because I've created an overload method of the paint set tile in the tile chunk class, which basically takes a game object instead of a tile. And a similar thing has happened for the paint area, where it takes an x and y, but the overload takes a game object instead of a sprite. That's one. Sorry. Was there anything else on this? Nope. Okay. Just showing the tile chunk then. This overload method, it looks a bit complex, but it's not. So basically, since we're not actually using this, where is it? Get tile. Which had this bit of maths which would convert the mouse coordinate to be an index in this chunk. We have to do that bit of maths here. So first off, we take the starting coords from the x and y values passed in, but we have to round them to an integer because we're using them as an index. And we've just got some debugging stuff which I wanted to display in the inspector, so you can have that. I'll just say what starting coords were, what the x and y were, and where it's creating a new tile. I can get rid of that. Then we have game objects for the old tile, and the game objects for the tile that's being created. And the int order is just the sorting order to be set. So first off, for each of the cases, it just basically varies which row you're taking out of the chunk, as we explained last time. Because we have like 5 arrays to represent the rows, because we can't have serializable 2D arrays. So first off, we store the old tile game objects in the old value. Then we create a new game object. Basically, we're instantiating an instance of whatever was passed in, so that'll be the new tile, at the old tile's position and the old tile's rotation. Then we set in the actual array of tiles that we're storing, we get the tile off a new game object and store that. Then we get the sorting order off the old tile and set it to be on the new one. And then we set this, so this is the new tile. We're setting its reference to its game object to be the correct game object, basically. And we're saying that it's not a blank tile because we painted it. And finally, we set the parent of the object. So this would be the chunk. So this basically just sets it to be the instance of chunk, or the old game object's parent, because it'd be the same thing, really. Hopefully that makes sense. And then we just destroy the old game object, and that basically just creates us a new tile. And then we break. That's it. I didn't really explain. Oh well. Hopefully that made sense. So yeah, so basically we're storing the old game object, creating the new tile with the old one's values, but with the new prefab. We're transferring all the values like the sorting order, and setting the reference to be the game object, and setting the reference to be the tile script on the new game object that we've created. So we're storing that in the array, and then we are just destroying the old tile because we no longer need it. And that's done for all of them. And similarly, on the paint tiles and area, we've got a new overload where we take a game object instead of a sprite. And what we do is very similar. We're basically just going through all the tiles, and if the position of the tile is within the bounds of where we're wanting to paint, we round off the X and Y positions of the tile, and we then call the set tile method with the rounded X and Y coordinates and the position, the game object that we passed in, but we want it to be a tile, which should probably be T. No, never mind. It doesn't matter what it's called. But yeah, so that just basically just calls the new method here, which sets the right tile, and you're good. Okay, so finally we get onto the inspector bit. So we created a GUI. That'll be an ugly looking one, which is something I'll address in the next episode, because that's going to be about making it look a bit more user friendly, I guess would be a better word for it, but whatever. So first off, we just got a little label to separate out our sprite control. Then we've got a button for refreshing sprites, and we just got a label to say how many sprites we found. And actually, I probably didn't need to have these on the same button actually, so I'll just yeah. Let's load sprites. I'm just gonna put them all under one button, so it refreshes, then processes. And one neat little trick actually I found was for each basically this asset.getAsset preview, which basically you can see there, it's basically what they use in the inspector to draw these little images, so we can use that ourselves to avoid having to get offsets and to work out where in the texture or the sprite we want to actually draw it. Sorry, my chair's creaking because it's a piece of shit and dying on me. Yeah, so that's what we use to draw the actual image. And that's quite easy to do, actually, because it's a Unity built thing that I use for their editor. And then we draw a button for this texture that we get from the getAsset preview. And if we press that button, we set the current tile to paint to be G, and that's what sets this value here with a tile that we can paint. And yeah, that's just expanded. So yeah, that's pretty much it. Again, I'll just show you. So if we just go on to paint single and hold down Alt and just paint these purple tiles. And there, the bloke's got a chin. A little bit shitty. So it's a bit finicky with the rounding. Because, yeah, it doesn't have that move in it, but whatever. So yeah, that was loading up resources and letting us set tiles so we can paint different ones. Let's create a new layer, see what happens. So active layer 1. Boop. Decrease sorting order. Yeah. Yeah, as you can see, still layers work. There's new stuff. So yeah. So cheers for watching. Like, comment, subscribe, all that shit. Go check out Loud.Quiet. The monthly update is nearly done. There will be a video on that next week about all the improvements I've done. Basically, what I've been doing is like loads of minor things that I needed to get done, which improve the quality of the game. So like a slightly better GUI for some things, just little bug fixes here and there, stuff like that. You know, it'll all be covered in the video, so it'll be good. Check out my shit on itch.io. Links will be in the description. There's like assets and little prototypes I worked on, a Maker Station, which was for my dissertation. That really bad RCR clone that I did, but you know, you gotta try it. What else is there? Not much. So yeah, like, comment, subscribe, all that shit. Bye.